Alright, this is Calculus AB 2009, number 6. The derivative of a function, got the old f prime graph here. We got a piecewise definition of it. It's g of x, whatever that is, for negative 4 to 0. So that's kind of like a semicircle. And then it's this 5 e to the negative x over 3 minus 3, this thing, for 0 to 4. Okay? Looks like it's continuous. The graph is continuous. There we go. It's got x-intercepts at x equals negative 2, and at x equals 3 natural log of 5/3. And the graph here is a semicircle, in fact, and f of 0 is equal to 5. So that's not on this. This is the graph of f prime. Right? So they're not talking about the graph of that. On the original graph, whatever that looks like, f of 0 is equal to 5. That makes me think there's going to be some fundamental theorem coming up here. Okay. For all the values between negative 4 and 4, find all values of x at which the graph of f has a point of inflection. Okay, so how do you find points of inflection when you're looking at a derivative graph? So point of inflection, by definition, is where the second derivative changes sign. And the second derivative is the slope of the first derivative. So it's where the slope of this changes from positive to negative, or vice versa. So that would be anywhere where this has a maximum or minimum. So f double prime changes sign where f prime has maximum or minimum. That is a good thing to know right there. And it doesn't have to be like a smooth minimum like that. This also counts because the second derivative doesn't have to exist there. It just has to change sign. So that means we have inflection points at x equals negative 2. Right there, there's a minimum on the derivative graph. And right here, because there's a maximum on the derivative graph. Because f double prime changes sign. All right. Part B, find f of negative 4 and f of 4. All right, so we get some fundo theorem here. If I want to find, if I've got f of 0 and I want to find f of negative 4, I would do this, negative 4 to 0, f prime of x dx. Fundamental theorem says take the integral of a derivative, you get back to the original function, so that'd be f of 0 minus f of negative 4. That's the fundamental theorem of calculus, what we called part 2. All right, so this is not a calculator problem. This is the area here. So this area is the area of a rectangle, which is a 2 by 4 rectangle, 8, minus the area of this semicircle, right? Because we're talking about the area that we want is the area between the curve and the axis. So I got to do this rectangle minus the semicircle. This is a circle of radius 2. So the area of that circle would be pi r squared, or 4 pi. So half of that circle is 2 pi. Right? So that is this area. Oh, look, the end of this pen lights up. Isn't that cool? So I got 8 minus 2 pi, that's this, is equal to f of 0 is 5, they told me that, if we're going to use fundamental theorem, they got to give us a point when we've got the derivative graph, and that's what they gave us, minus f of negative 4. And f of negative 4 is what I'm trying to find. So math is going to happen now. I'm going to move this over to the other side, and then I'm going to subtract 8, and I'm going to add the 2 pi. So there it is. And yep, just going to check on that scoring guide, make sure that that's good. And now we're also supposed to find f of 4. So that's the same game, except, ooh, my pen is lighting up when I don't necessarily want it to. So going to go now from 0 to 4. So that's f of 4 minus f of 0. And this time, from 0 to 4, I've got an actual function that I have to deal with here and find an antiderivative and all that. So let me do that here. I'm going to go from 0 to 4. I need the antiderivative of 5e to the negative x over 3 is the same as negative 1/3 x. Minus 3 dx. What's the antiderivative of this? Well, the antiderivative of e to the something is just e to the same thing. But if there's just a constant multiple here, and this is just x to the first power, then I just have to divide by that. And dividing by negative 1/3 is the same as multiplying by negative 3. Right? So if you think about how that would work when you do, if you took the derivative of this with the chain rule, you'd have to multiply by the derivative of what's inside. That would cancel that out, and you would get back to this. Minus the antiderivative of 3 is 3x. It goes from 0 to 4 there. Okay, so that's 5e to the negative 4/3. Oh, dang it, forgot that. So negative 15e to the negative 4/3 minus 12, and then minus, when I plug the 0 in here, e to the 0 is just 1, so minus 5, and then when I plug that in, I get 0. Oh, wait a minute. E to the... I think I messed up. Hold on a second. So, plugging 4 in there, that's all good, but when I plug 0 into this, I get... I don't get 5, I get negative 15. Right? There we go. Okay, I think I'm good now. I just forgot that negative 3 there when I was plugging the 0 in. Okay, so that is equal to negative 15e to the negative 4/3 minus 12 plus 15 plus 3. This is some math happening here, huh? Okay, so that is this. So now I have negative 15e to the negative 4/3 plus 3 is equal to f of 4 is what I'm trying to find, minus f of 0, which is 5. So f of 4 is equal to, add the 5 over here, it's negative 15e to the negative 4/3 plus 8. I'm adding the 5 over there. Now that's crazy. That was a big chunk of the points for this, for finding that, for doing all that fundamental theorem stuff, finding the antiderivatives of that right, and all that. All right, I'm going to flip that paper around, give myself a little bit more room to do part C. All right, for For the x values between -4 and 4, find the value of x at which an absolute maximum on a closed interval, got to check the endpoints, occurs. Oh, and I don't know why I included that little table here. That's for the next, some other problem. That has nothing to do with us. There, that's better. Put that table away. Okay, so the absolute maximum is at endpoints or where f prime goes. If we want a maximum, we got to go from positive to negative. So those are the things that we're looking for. Where does f prime go from positive to negative? It looks like it does right there. So I need to check x equals -4. I need to check x equals 3 natural log 5/3, and I need to check 4. Right? Okay, so let's see. We can do that. I have f of -4, and I have f of 4 from before. So this is, let's see, this is 2 pi minus 3. I'm just looking for my answers from up above. And this is 8 minus 15 e to the -4/3. That's not super helpful for this game here, because boy, how are we going to figure out what that is? So maybe this is not the best approach. If we look at this and we see that the since f prime is positive, in other words, f is increasing from -4 to 3 natural log 5/3. It's increasing this whole time because the derivative, this f prime, is positive that whole time, and decreasing from x equals 3 natural log 5/3 to x equals 4. The absolute max is at x equals 3 natural log 5/3, and that is a solid argument for that there, without actually having to find that. Did they ask what? No, they just said find the value of x, so we don't need to actually do the calculus again like what we did in part B. So that will work there because we're only increasing and then only decreasing, so that has to be the absolute maximum. All right.